Hello, and welcome back to Learning with Lee. In today's episode, we are going to examine character traits, as well as then how we can create C++ style strings. In particular, we're going to look at this basic string class, as well as then this here, which just frankly happens to be a version of basic string that's already type-deffed so as it takes in a character. So, to begin with, what are character traits? And character traits itself happens to be a templated struct, as you can see in here. Well, if I can bring that up for a second, in here, that happens to be used in general by basic string, in order to perform a lot of the underlying logic that it uses for copying around different characters, moving characters around, assigning different things, and handling the behind-the-scenes information without necessarily having to specify whether it's a character that we're dealing with, whether it's a wchar t, or whether it happens to be your own unique version of a character that happens to be something specific to a particular language, to a particular whatever you want to give it. So in case I want to have a custom one that dealt in Tolkien Elvish, I could have that if I wanted to, and I put the time into doing that, and I could basically define its character traits, and then have a basic string that deals with that sort of class. So that happens to be something that you can actually do with this, and in general, character traits is going to be very similar to a lot of the stuff that we've already covered in going over the C-style strings and some of the functions that existed for them. So this is going to just be more or less a C++ adaptation of a lot of that. So one of the first things that you'll see in here is that we have these two character type and two int type, and you can see what they are down here for these four up here, in which the two character types take in an integer, and it returns whatever their corresponding character is in that type of character. So a char, it ends up giving us something that's in ASCII. For a wchar, it ends up giving us something that is a bit different because it's basically using Unicode for that, and as a result, it ends up being a little bit different. Though, for now, these ones here, if I ended up going with some of the same sort of stuff up here, such as copying that there, don't need that L there, and then build it and run it, you'll see that for this part here, it ends up treating it the exact same. The major thing is that for a wchar, it has the ability to have multiple bytes. Normally, characters are only a single byte of data, whereas a wchar could be 2 bytes, could be 3 bytes, could be 4 bytes, could technically be more, but in general, you're never going to have more than 4 bytes of information to represent even a Unicode character. That happens to be the major difference between those, and one of the major things that you'll also notice with wchars is that we can't just use normal couts for them, because you can see down here we end up outputting this 2 character type and 2 int type down here, and we have to use wcout, because in case I use a normal cout, it is going to give us some errors. So if I do that and then run it, you'll notice how down here it gives us this number out. It doesn't actually give us the character like it did previously. So instead I actually have to use wcout. And in general, you can just prepend a w to most of the different functions that you would be using with characters, and it'll end up working out correctly. Occasionally they aren't named so as that that's the only change you have to make, but in general, for the majority of things that are in C and C++ libraries, that's the only change you have to make. Then, beyond just being able to convert between its integer type and its character type, which, to be frank, if we were doing this in C++, if we were doing this in C, and technically we could do this in C++ because it's based off of C, we just do this by basically casting from an integer to a character and vice versa. However, this one here is designed to abstract us from that underlying mechanism so we don't have to know how it's actually implemented within here. However, you can see, if I hover over it, it ends up just doing this cast right here to this templated type of the argument that gets passed in. So you can see that really all that they're actually doing happens to be doing these conversions like this. So that happens to be worth considering, but it is not something that we really need to focus on too much right now. Then down in here, you can see there's a few other things related to basically manipulating a string of some type of character. And this basically handles it similar to C-style strings, and it deals with pointers. And that's because the underlying stuff for how strings work is that it does use pointers, but it keeps all of that hidden from you in general. You can do some stuff with pointers, as we'll see when we get down to the declarations here, as well as also when we get into some of the functions in the future with strings. But one of the major things about object-oriented design and programming is that you end up hiding a lot of the memory usage, a lot of the specific implementation stuff behind functions, so as that whoever's using you doesn't have to care about that stuff. To begin with, it has things such as the ability to copy, to move, and to assign characters. So one of the first things I'm going to point out is I've left this uncommented to make a specific point about all of these functions. And that's that all of these functions that do these copying, move, and assigning do not append on a terminating character, a null terminating character. So basically, and you can see that down here because it ends up having these values down here. Because what ends up happening is that initially is I create this string here. And technically, to be fair, at this point here, actually, if I see out it, because of the fact that it ends up having this being terminated by a null terminating character there, it should actually null terminate us correctly when I do this. So build it, run it, and you can see here, it ends up null terminating correctly. However, with copy, when I try to append something on using copy, it ends up overriding that null terminating character, and it does not append on this one's null terminating character unless I go far enough to grab that character. So that's an important thing to note and to consider. So it gets the copy done correctly, but it doesn't actually append that on. So that is one thing, but allow me to also state this just flat out. C traits are things that, in general, you and I are never going to actually use. We're just going to end up using strings down here, and occasionally basic strings of type wchar t. But that happens to be not something we really need to worry about too much. But it is good to know about these just so as we can visualize how these down here actually end up working. So it has this, and this is very similar to just stir copy, and really these are based more upon mem copy, mem move, and a couple other values, such as in this case here, mem set for what assign is. And really they are somewhat modified and updated versions of those older functions. As even Strauss-Tripp himself says, the major thing about copy versus move is that move, your target and your source can be overlapping. With copy, that's not allowed because you will wind up in a problem of it trying to copy stuff and it'll overwrite stuff and you will wind up with inaccurate results. Whereas with move, it's slightly less efficient because it can end up moving stuff and then basically overriding information where you already had it, but still keeping that original set of information correct. So in this case here, I just ended up moving, I repeat, up to the beginning here, and as you can see, it overwrites that, does that, and there's other stuff that we could do in case we want to actually prepend it, but that happens to be outside of the scope of at least today's episode and outside of the scope of character traits. And then assign basically is just doing memset, and that you can see down here, I just assigned a space to the first 5 characters of it, and now you can see down here we have these 5 characters, they're spaces. So those are a few of them. There's also some functions in there for comparing 2 different characters, just to do equals, to do less than, and as a result of doing less than, as well as also doing equals, you can effectively get greater than out of it, but that isn't directly in there, as well as then there's a few other things for comparing it, which similar to stir comp that we covered in the previous episodes. So it does have a few more things, but really it's not that important for us to delve any further into it and how it actually happens to work. So let's take a look now at basic string. And basic string is the actual class behind C++ style strings. Nearly everyone who deals with C++ style strings will use this string class here. I've really never seen anyone actually use basic string directly. However, it does have some uses in case you do need to have, say, a Russian or Japanese language version of your program released in addition to an English language one. Whether or not you happen to be using chars or wchar t's is going to vary depending on which release version you use. So that's important to note. Another important thing that you might have actually noted a bit earlier on is I have this little L right here in front of A. And that's actually different from this L here. And I wanted to have these both here to point out this difference here. Having an L after an integer specifies that it's a long. It's similar to if I put an F after it, it would specify that it's a float. But the reason why it's complaining there is the fact that this does not expect to take in a float-style character. However, then this L here is similar to saying that this integer is a long. However, it's saying that this character is a wide character or a long character. It uses more bytes than normal. So you'll also see down here how I end up doing this for this wchar pointer and setting it equal to a long of ABC down here. And you see that it ends up outputting these correctly. However, if I don't do that, if I just have this as it's pointing to the string ABC, that will actually give us errors. So it is important to note that if you do use wchars, you do need to have this prepended L when you are dealing with your strings for it to actually be able to handle them correctly and deal with it correctly. So it is worth noting, it is important to consider to do that, and it is a valuable asset to use. So actually, let's also get that mem set in there just to make certain that you can see down here now how that's all cleaned up, how it's done correctly. And once again, this just is a good thing to do in general when you're dealing with character arrays, is to make certain that you initialize everything to this null character. So down in here, there's a few different ways in which you can end up declaring a type of basic string or of string. To begin with, you can just pass in some constant string like this, or similar to this one up here, or similar to some of the other stuff that we did in terms of where we would just assign it to a pointer like this. However, you can also then do it by creating a pointer to something and then passing that in. So if I want to do that, I could do that value. I could do something such as this +1 in case I just wanted to get B and C out of it. And those all happen to be valid ways of dealing with it. In general, you're either going to do this or you're going to pass in some other string, some other type of C-style string. Doesn't really matter. It's designed to be able to handle almost all of those. When we get into iterators, you'll see that it has some that end up being using iterators for basically finding where to begin and end a string when you're creating one. However, this is good enough understanding of it for now, is that you can pass in this constant style string, you can pass in a pointer to a character array or to a string, or you can end up passing in another C++ style string. So if I wanted to here, I could also just do CSTR, and then that also will then build and run correctly for outputting it. So that's really all that we're going to cover in today's one. We now know how to create a basic string, which happens to be the C++ style of string, as opposed to the earlier C style of string that we were looking at. And we know a bit more about how it works under the hood because of character traits. In the next episode, we'll begin looking a bit more at the things you can do with a C++ style string that you can't necessarily do with a C style string, or at least this slightly cleaned up version of C style string functions and methods that existed, and how they happen to exist in C++. Thank you very much for watching. Have a wonderful day.